to Adarsh Vidyalaya Matriculation online class. Welcome to all children. Class 8, Subject Science, Unit 3, Light. Today, let's study about the two instruments which are working on the principle of multiple refraction. There is Kaleidoscope and Periscope.
You learnt about the law of reflection. Can you think of any instances where it is put to use? If I give you a couple of mirrors and ask you to watch your friends without you being seen, what will you do? Periscope and kaleidoscope are useful examples of the law of reflection at work. Let's understand these and build simple version as well. A periscope lets you look around walls, corners or other obstacles. Submarines are under the sea level most of the time. Submarines have periscopes so that people inside can watch what is on the surface of water. Periscope is based on law of reflection. It consists of reflecting mirrors at opposite ends of the tube container. It is important that the mirrors are placed at 45 degrees of angle. Because light always reflects away from a mirror at the same angle that it hits. In a periscope, light from an object strikes the top mirror at 45 degrees and bounces off at the same angle. This sends light directly down the tube and onto the lower mirror. This mirror, also at 45 degrees angle, reflects light directly to your eyes. Some advanced periscope use a combination of lenses and mirrors to achieve better results. Activity. We can construct basic periscope with A4 size card sheet paper and acrylic mirrors. Paper is folded into square tubing. Two openings are made at the opposite side, and two acrylic mirrors are inserted such that they are at an angle of 45 degrees to the side walls. One opening points towards the field while the other is used to observe the field. If you don't have acrylic mirrors, you can also build similar one with regular glass mirrors. Try changing the angle of one mirror or both mirrors and check if periscope still works. Can you build similar periscope which will allow you to see behind you? Kaleidoscope is a perfect blend of art and science, which means instrument for viewing beautiful forms. You would have probably seen one of these in your childhood days. Since its invention around 100 years back, many variations of these are available in the market. There are generally four basic components of kaleidoscope: eyepiece, external body, mirror system, and object chamber. It is the mirror system that creates the magic. The mirror shape, the number of mirrors used, and the angles at which they are joined combine to produce an image you see. When two mirrors are used, they are arranged in V shape. Three-mirror system can be arranged in any form of triangle as long as sum of three angles is 180 degrees. Most popular ones use straight mirrors in an equilateral triangle. Object chamber holds objects which are replicated by mirrors. These are normally colorful, small, translucent. These might be plastic or glass beads, chips, seeds, crystals, and marbles, and the list is endless. The colors, shapes, forms, patterns combine in ever-changing, never-repeating relationship. Let us build a basic kaleidoscope. We will use three acrylic mirrors and tie these with rubber bands. Instead of using conventional objects to create pattern, we will use paper and draw various patterns with sketch pens. Paper disc painted from inside is locked in a toothpick attached to one mirror. With one eye closed and other placed inside the triangular cavity, kaleidoscope is pointed at the light source. Paper disc is slightly rotated to generate different patterns. This arrangement enables us to build kaleidoscope quickly and explore different patterns. If acrylic mirrors are not available, you can use regular glass mirrors as well.
Hi friends, I'm sure you've all heard that light travels in a straight line. It's called the rectilinear propagation of light. But are you ready to try your magic trick with me, where we are going to bend light? For the magic trick, I just need you to get a transparent glass like this filled with water. So pause the video here and go and get a glass of water. Are you ready with your glass of water? Next, I'll be showing an arrow on the screen, and you pause the video when you see the arrow and hold up your glass of water in front of the screen, something like this, and look at the arrow again and tell me, what do you see this time? Did you see the magic? Did you see the arrow changing its direction? It's happening due to bending of light. This is called refraction of light, and it's going to be the topic of this video. And then, as usual, we'll finish off with our top 3 questions on this topic. I have this torch here with me. When I switch on the torch, it gives out a beam of light. A beam is composed of many rays of light. As you can see, each ray is traveling in a straight line. Now for simplicity, let's consider a single ray of light. Now how do I bend this ray of light? I can't just grab the ray of light and bend it, right? So what do you think I need to do to bend the light? You might be thinking of using a mirror. So a mirror certainly changes the angle by reflecting back the light. But what if I ask you, I want the light to continue downwards and still bend it? Then what do we need to do? So you need a transparent material like glass or plastic here. Let's imagine there's a large glass block kept here, and I'm going to shine this torch on the glass block. Again, we'll consider a single ray of light for simplicity. Can you see the ray of light bending as it enters the glass block? This is known as refraction of light. There is also a partial reflection when the light hits the glass surface. But we'll ignore that for this video, and our focus will only be on refraction of light. So what have we learned till now? Light travels in a straight line as long as it's traveling only in one material. So as we saw here, as long as it's traveling only in air, it's traveling in a straight line. And then if you look only at the glass part, light is traveling in a straight line. But when light travels from one material to another, so here from air to glass, it bends. And this bending of light is called refraction of light. So here's the fancy definition of refraction of light. Refraction of light is defined as the change in direction of light when it's traveling obliquely from one medium to another medium. So what does this all mean? Let's break it down here. So change in direction means bending of light. Obliquely means the light is incident at an angle. And the word medium means material. For example, air, glass, water, these are all materials. You may also see the term optical material because optical refers to light. And for refraction, remember that the material needs to be transparent. Let's place the definition of refraction of light on our concept board. Have you seen any simple everyday examples of refraction? One thing that you might have noticed, or you can try yourself, is take a pencil and put it in a glass of water. The pencil will appear bent. It's due to refraction of light. Another example is, if you go and stand near a swimming pool, it actually appears shallower than it really is. And of course, the magic trick that we saw at the beginning of the video. So do go ahead and show it to your friends, but don't tell them the secret. And there are many other examples of refraction. But we'll look at those in detail in a separate video.
When light enters from one medium to other, there is a change in its direction of propagation, and it appears to bend. The extent to which bending of light takes place is expressed in terms of refractive index. Refractive index is a constant obtained from the ratio of the sine of angle of incidence to the sine of angle of refraction. According to the laws of refraction, the incident ray, the refracted ray, and the normal at the point of incidence lie in the same plane. For two given media, the ratio of the sine of angle of incidence to the sine of angle of refraction is a constant. Sine I upon sine R equals n. This law is also known as Snell's law. The constant ratio of sine I and sine R is called the refractive index of the second medium with respect to the first. If light travels from air to glass, then sine I upon sine R equals NAG, where NAG is the refractive index of glass with respect to air. Refractive index N equals speed of light in vacuum upon speed of light in the medium. The refractive index of a medium depends on nature of the medium, physical conditions, color or wavelength of light used. The refractive index of a medium is more for violet light and less for red light.
Let's see a quick recap. In today's session, we studied about the instruments working on the principle of multiple reflections. Kaleidoscope is a device which produces numerous and wonderful image patterns. Periscope is an instrument used for viewing objects which are over and around another body. The bending of light due to change in its speed as it travels from one medium to another is called refraction. The amount of bending of light can be measured by a specific quantity is called refractive index. The index of refraction is the comparison of the speed of light in air with the speed of light in certain medium. As the speed of light in air is always greater than any other medium, the index of refraction in any other material is always greater than 1. The larger the index of refraction, the greater is the amount of bending of light. Thank you.